Bismillahirrahmanirrahim. Welcome, dear students. I hope all of you are fine and enjoying good health. This is our third lecture, and the topic that we are going to discuss in our third lecture is wave motion. Before discussing wave motion, first of all, we will explain few features of a wave. These are the few terminologies that we will discuss in today's lecture, such as vibration, frequency, time period, and amplitude of a wave. And I hope all of you will have a clear concept about these terminologies by the end of this lecture. The very first term that we are going to discuss here is vibration. What is a vibration? Now, before discussing its definition, let us consider the example of a vibrating pendulum. As you can see in the figure that initially the pendulum is at its mean position B. When we apply a force on the pendulum, it will move towards its extreme position A, and then due to restoring force, it will come back and move towards mean position B. But it will not stop at this point and continues to move and reaches another extreme position C. And then again, it will come back towards its mean position B due to restoring force. So, this complete round trip of this pendulum about its mean position B is known as one vibration. So from this, we can define that one complete round trip of a body about its mean position is called one vibration. We can also represent this motion of a pendulum, this vibratory motion of a pendulum on a graph. Now, let us consider this is the mean position B. This is one extreme position A, and this is another extreme position C. Initially, the bob of this pendulum was at its mean position B. Then we apply a force and move it towards extreme position A. It will move towards its extreme position A. Then due to restoring force, it will move back towards its mean position B, but it will not stop at B. It will continue to move due to inertia and reaches another extreme position C. And then again, due to restoring force, it will come back towards its equilibrium position or mean position. Thus, the bob of the pendulum completes one vibration or one complete round trip about its mean position B. This complete round trip of the bob of a pendulum is known as one vibration. Now, the next term that we are going to discuss here is frequency. Frequency is basically that how many number of times a vibrating body vibrates about its mean position in 1 second. Let's suppose if a body is vibrating about its mean position, or if it completes one vibration about its mean position in 1 second, then the frequency of the body will be 1 Hertz. Here, Hertz is the unit of frequency. Now let us consider the example. Now look at the figure. Here we can see that there are two complete vibrations. This is one vibration, and then from here to here, this is another vibration. So this body completes two vibrations in 1 second. So we can say that the frequency of this body is 2 Hertz, which means, so we can conclude that from this figure, frequency is basically the number of vibrations, the number of harmonics or oscillation that are completed by a vibrating body.
Now, we will discuss about units in which the frequency of a vibrating body is measured. A number of units are used for measuring the frequency of a vibrating body or a vibrator. such as hertz, cycles per second, and revolutions per minute. But hertz is most commonly used as a unit of measuring frequency of a vibrating body. Now, we will discuss that what is meant by hertz. If we are saying that the frequency of a body is 1 hertz, what does it mean? It means that a body is completing one cycle or one vibration in 1 second. If the frequency of a body is 50 Hz, then it means that body is completing 50 cycles in 1 second. Similarly, if a body has 100 Hz frequency, it means that the body is vibrating or the body is completing 100 vibrations in 1 second. The bigger units that are used to measure frequency are kilohertz, gigahertz, and megahertz. Here, kilo, giga, and mega are the prefixes that are used to represent a large quantities. As we have already discussed in 9th grade physics, that what is meant by prefixes. Prefixes are basically the words and letters that are added before SI unit and stands for multiple and submultiple of 10. I will not go in detail of this topic because you have already studied this topic in your 9th grade physics.
This is something that is related to the time. So basically, now look at the figure. Here we can see that a wave have a number of vibration. From here to here there is one vibration, then from here to here there is another vibration. So the time that is taken by any vibrating body, the body may be pendulum, maybe a ball and bowl system, maybe a spring, maybe a rubber band. So the time that is taken by that vibrating body to complete this one complete round trip or one vibration, that time is known as time period. If body complete one vibration in 1 second, then the time period will be equals to 1 second. Here, second is the unit of the time period. But if a body complete, let's suppose, if a body complete one vibration, this is the vibration that is completed by the body. If it completes this one vibration in 2 seconds, then the time period of this vibrating body is 2 seconds. So we can say that time period is basically the time that is required by a vibrating body to complete one complete vibration.
Now we will discuss that what is the relationship between frequency and time period of a vibrating body. The period of a vibrating body, as you can see here, is equals to 1 over frequency, or we can say that the frequency of a vibrating body is equals to 1 over period or 1 over time period of that vibrating body. Since the symbol F is used for representing frequency and the symbol capital T is used for representing time period or the period of a vibrating body, therefore we can also write down these equations as T is equals to 1 over F, or we can say that F equals to 1 over T. So from these equations we can also conclude that the frequency and time period of a vibrating body is inversely proportional to each other, which means that if one quantity increases, the other one will decrease, or if one quantity decreases, the other one will increase. If a body having higher frequency, it means that the time period of that body will be low. Or if we can say that if the frequency of a body is low, it means that its time period will be high. Now we will discuss or we will solve a few problems that will help us out to have a better understanding about frequency and time period of a vibrating body. Now let us consider this question. A period of 5 seconds corresponds to a frequency of how many hertz? So here in this case the period of a vibrating body, that is T, is given, that is equals to 5 second, and we have to calculate the frequency of that body. Now we already know that the formula of calculating frequency is F equals to 1 over T. So here when we put the value of T, it will become 1 over 5. So by dividing we will get 0.2 hertz. So 0.2 hertz is the frequency that corresponds to a time period of 5 seconds. So from this question we can also conclude that if the period of a body is high, then its frequency will be low. Now let us consider another question. Here in this question it is given that a child in a string makes one complete back and forth motion in 3.2 seconds. Here 3.2 seconds is the period of a vibrating body. This statement provides information about the child's. This statement is providing information. Number one is about period or the time period that is given here in this question, that is 3.2, because we are given that one complete back and forth motion is completed in 3.2 seconds, and we have already discussed that if body complete one cycle in 1 second, then that is called its frequency. So here in this case 3.2 is the time that is required to complete one vibration. Therefore we can conclude that the period of a vibrating body is given, and the other thing is the frequency that we can find by using the formula F is equals to 1 over T. So time period is given, therefore we can calculate the frequency. So we can conclude that from this statement we can find two things about vibrating body. Number one is the period, and number two is the frequency of a vibrating body.
So the next terminology that we are going to discuss here is amplitude of a wave. Now before discussing its definition, let us consider an example. Let's suppose that this is a pendulum. Now initially it is at its mean position. Let's suppose it is at position O. Now when we apply a force on it and move it toward extreme position A, so the distance between this mean position and this extreme position is known as the amplitude of the vibrating body. Now look at the figure given below. Here we can see that this is the mean position and these are the extreme positions of this wave. So the distance between from mean position to extreme position is called amplitude. This is amplitude, and again this is also the amplitude of this wave. This is also the amplitude, and this is also the amplitude. So from this figure or from this wave we can conclude that the maximum displacement covered by a vibrating body about its mean position is known as amplitude. Now the next term that we are going to discuss in today's lecture is damped oscillation. This is a very important topic, and we can also observe this phenomena in our daily life. Let us consider the example of a pendulum, or let us consider the example of any vibrating body, such as you can take the example of a ball in a bowl system. Initially we will notice that when we release the ball, the amplitude of vibration of the ball in the bowl will be like this, and with the passage of time the amplitude of the vibration of this ball will start decreasing. Why the amplitude of the vibration starts decreasing? This is due to the resistive medium or the resistance force that is present in the medium. So, from this we can say that the oscillations are the harmonics that are produced in the presence of some resistive medium are known as damped oscillation. We can also understand the concept of damped oscillation by looking at this figure. Here we can see that initially the amplitude of vibration of the body is very large, and with the passage of time, due to the friction or due to the resistive forces, we notice that the amplitude of vibration starts decreasing. So such kind of oscillations are vibrations in which amplitude of vibration decreases with time are known as damped oscillations.
Now, this is your homework. Learn definitions of frequency, time period, and amplitude. After learning these definitions, also write down on your loose sheets. Thank you so much. This is all about today's lecture.